data processing models, or the DFD, data flow diagram. It is used to model the system data processing. It shows the processing step as data flows through the system. It is very important in the analysis process because it's simple and it has four samples: the process, the entity, the data storage, and the data, the arrow. And it shows the end-to-end processing of the data. The flow diagram is used to model the system from functional perspective, which means it is used only to model the functional requirement. We don't use data flow diagram to model the non-functional requirement. Data flow diagram is helpful to give an understanding of the system because it documents and tracks how the data associate with the process. In addition, the DFD could be used to show how the data is gonna be exchanged between the system and other system in its environment. Allows us to see the whole system as a picture of nodes, and these nodes are connected with edges. The node represent a process, and the edges represent the data flow, and might be the nodes represent stores of the data. We will show you an example. Next slide. DFD is one of the most commonly used systems modeling tools, and we use data flow diagram when we focus on functions more than the data. And if we are focusing on the data more than function, might be we use AR diagram, and we de-emphasize on the DFDs. Data flow diagram is used to show how the data flowing in the system and where the data is going to be stored or transferred by the system. And as you can see here, this is the system boundaries. These are the processes for that system, and these arrows represent the data transfer between these processes, and this is the boundary of the system. And these called external entities. It might be external system that interact with your system. This external system might provide information or data to the system, or might receive information from the system. There are many levels. The first level called context diagram, or level 5, which shows your system and how the external entities interact with your system. This is called the top level, or context diagram. Level 0, it shows the major processes, the major functional requirement of the system. Right? For example, we have process A, B, C, D, and so on. This is called level 0. The detailed levels, or called level 1, it takes each functional requirement here and start analyze it in more details. As long as we go further, we give more information, more details about the processes and the data associated with each process. Okay. This slide shows the standard symbol we use. The process or transfer we use as a bubble, and this process used to transform input to output, and the name of the process should be used as a verb. because it's a process. A good name consists of a verb object phrase such as a validate input or compute tax rate. We don't use a noun as a name for the process. In some cases, it might be a process will also contain the name of a person or a group of people, a computer, along with an action verb. As you can see here, the symbol of a process, it might be used as a rectangle with a rounded corner or a circle. It has a process ID. The process names or process description should be an action verb, and each process it should has an input and output. There is no process without input or without output. Now we have source and sinks entity. The source and sink entity, it might be a source or sink process or entity or a data source. What's the source? Sources might be a provider of the data or the data out of the source of the system. It represented by an arrow goes out of the entity. The sink, it means the recipient of the data or data into the source from the system. It goes in. The same entity or the same process or data source, it might be source and sinks at the same time, as you can see here. External entity can be source and sinks at the same time. In addition, the process, the data stores are also could be a source or sinks at the same time. Data stores represent as you can see here. When arrows goes into the data stores means we are storing the data, which means we are writing on the database or in the file. When the arrows comes out of the data stores, it means we are reading or retrieving data from the data file or the database. This is again about the data stores. Read or retrieve data is a store is used to model a collection of data packets such as files, tabs, databases, and so on. The store may exist as a necessary time delayed storage area between two processes that occurs at different times. And stores are connected by flows to processes. There are two types of flow related to the stores. A flow from a store is normally interpreted as a read or an access to the information in the store. A flow to store is often described as a write, an update, or possibly a delete. Arrow means the data, the name of the data, and it specify the direction of the data flow. A flow is represented as graphically by an arrow into or out of a process. The flow is used to describe the movement of chunks or packet information from one part of the system to another part. It represents a data in motion. Here, the arrows means data. Flows may be a movement of data or physical material. The same chunk of data, such as phone number, has a different meaning when it travels along the flow labeled phone number than it does when it travels along with the flow labeled valid phone numbers.